All right, guys. So in this video or the next couple of videos, we're going to talk about chapter 7 and what the concept of chapter 7 is about, using sample data to estimate the parameters. And the two section we're going to focus on this chapter is estimating a population proportion and estimating population mean. We're going to omit the standard deviation section 1. So pretty much up to this point, every single problem we've done in this class, the parameters always given from for a population, like mean of this population, the proportion of this population is such and such. So now in this chapter, we're gonna go backwards. We're gonna say, okay, well, what if the population parameter is not given? Can we still estimate it? Can we guess what that value is based on the sample data? So that's what this chapter concept is about. Is we're gonna learn a few techniques. Well, actually, this would be one of the inferential statistics technique to estimate the population proportion and the mean. In chapter 8, when we get to chapter 8, we'll learn another inferential statistics technique that is called the hypothesis testing. But let's get to this. 7.1. So the title is Estimating a Population Proportion. There's a few notation we want to get out of the way before we dig into the concept and the example and some other stuff in this lesson here. So first notation we have is the value p. So up to this point, I think we know mu and x bar. In this case, I think this might be new. P usually denotes for the population proportion. So population proportion, and p hat is denote the sample proportion. Those are the two notation for this section that you that you want to be able to be familiar with. And every time you see this notation, okay, that means population proportions or sample proportion. To start out this lesson here, we also have another definition. It says that the statistics value that estimate the value of a parameter is called blank estimate. So this is called a point estimate. Okay, so anytime you're trying to estimate a population parameter, and you can you have a sample data, and from that sample data you can use a single value to estimate. So usually this is referred to a single value estimate. Okay, and usually this come from the sample data itself. Okay, comes from the sample data. Okay, all right. So what's the purpose of this lesson here? Let's look at this through a question. Suppose we have this question here. Suppose we have a question that asks, okay, we want to find out, okay, do we really know what proportion? Another word for proportion is percentage, guys. So percentage. So suppose we want to know what percentage of gun owners in United States. Okay, so suppose that's the question that we're trying to figure out. There's study being done already. Suppose we don't know what that number is. So what we can do here is we can estimate this. We can say, okay, I can guess the answer. Let's say an answer I can guess would be 35% or 0.35. Suppose someone guessed that answer. So if someone guessing using a single value, this is called a point estimate. Okay. And if another person say, well, how do you know it's 35%? Well, I'm not too sure if it's 35%. So I'm going to go ahead and just guess using a range of values. Suppose we say just range of values. So if we're looking at range of value estimate, we say, okay, well, it could be anywhere between 20% to 40%, for example, or 0.2 to 0.4. So another person can guess something like that. Do we know which one is better? Well, that's the question there. The goal of this lesson is which is a better estimate. Okay, and that's the goal. So we're going to introduce what in statistics formally we're going to call this range of value when we estimate something. That's going to call the confidence level, the confidence interval estimate. And that's what we're going to introduce in this lesson here. But that's pretty much the goal of this lesson is, how do we estimate parameters using, sample data in a way that we're more confident or more accurate, which is a better estimate, is using a single value or using a range of values, and what will be the trade-off from the two methods. So let's start with the first example here. So this example one kind of capture what I just said there, and kind of go over things a little more detail. Hopefully it's a little more clear, kind of introduce the concept of this lesson 7.1 here. So example 1a, suppose we have a poll that of 1,487 adults were surveyed and 966 of them said they have a Facebook page. It says that obtain a point estimate for the population, for the proportion of all adults who have a Facebook page. So in this case, if we're asking for a point estimate, point estimate in this case would be the p hat. Okay, and the p hat in this case is the best point estimate, because from this data here, all we have is just a sample proportion that we can use in this scenario. So that's going to be our best point estimate value in this case. Okay, so the formula for p hat is going to be x over n. X is the number of people who respond that said they have a Facebook, and n is the sample size. So we're looking at 966 over 1487, and that's going to be around 0.65%. So from this sample, 1487, about 65% of adults said, about 65% adults says they have a Facebook page. Okay, just from that sample. So that's gonna be our best estimate for the value p. Where the value p in this case, so let's just go ahead and introduce the value p on the side here. So p in this case, that notation stands for the proportion or the percentage of all adults said they have a Facebook page. Okay, so p hat in this case 0.65 used to estimate the value p. Of course, we don't know that this is the correct one because we only look at one sample of 1,487 adults, and there's gonna be a lot more than 1,487 adults in the United States. So this is probably not the best estimate here. Suppose we want to look at another sample data, another poll of 1,487, another random group of 1,487 adults were surveyed, and from this sample data, not 966, but 1,115 of them said they have a Facebook page. So we want to find a point estimate for this proportion of all adults who have Facebook page. So in this case, our p hat is gonna be our point estimate again, because we're using the sample data, and that's gonna be x over n. X in this case 1,115, n is 1,487, and that's gonna be roughly around, if you use a calculator, and that's gonna be roughly around 75%. Okay, so from this sample here, we have 75%, around 75% adults says that they have a Facebook page. So two different samples, same sample size, yield two different point estimates, two different p hats. The question now is, which is the better estimate? And that's what this question, right? Is the estimate in part A better than the point estimate in part B? How do we know that? How can we be sure that this is better than the other one? Both of these values are just a single value. We don't know how close we are to the actual value p, where it's the true proportion of all adults said that they have Facebook. There's no indication how far off, how close. So certainly we can't tell which one is better. So what we say is neither one is better. All right, since each of those guesses is a single value, single estimate value. Okay. so there's no telling. So there is no telling how close or far off is the estimate. Okay, so certainly we can't say, you know, part A's estimate is better than part B. However, if we do this, okay, if we guess that, suppose we obtain another p hat from a different survey, and we say that if we guess that p hat is, you know, 65%, and we can say, okay, well, from that 65%, we can say give or take 5%. Okay, so if we say, okay, let's go with this estimate there, and then we're not gonna say, okay, the p-value is 65%, but instead we're gonna say the p-value is, you know, around 65%, give or take 5%. What does that mean mathematically, right? So in terms of mathematically translate that sentence there, that means that the p-value is, you know, either 0.65 plus or minus 0.05. Okay, so give mean add, take mean minus. So this becomes, you know, this becomes here, p is the proportion of all adults that said they have Facebook, is between you know, somewhere, you know, 0.65, which is not 0.65, sorry, it's now somewhere between 60% to 70. How do we get that? We take 0.65, subtract 5%, so we get 0.6, and then we take 0.65, add 5%, we get 70%. So this now is a new way of estimating the true proportion of all adults say that they have Facebook. So instead of using, you know, a single value 0.65 or a single value 0.75, we say, you know what if we're just gonna say it's around, or it's between, somewhere between 60% to 70%, and that right there is come from the way we, you know, sometimes guess in real life is, okay, give or take, meaning is kind of, you know, around that area, but not exactly that single value. So this is our technique in this section, that is constructing this range of values. But in statistics, you know, so this here, the way of it, we estimate this here in statistics, right? And statistically speaking, we can say that answer, we can estimate that answer with, you know, certain level of confidence. Okay, all right, so the level of confidence, how we define that in this class, is gonna be a little confusing. I'm not gonna make it another video to explain what that is or the concept behind it, but when we get to the definition in the next video, I'll briefly talk about what that means. But to wrap this up, is pretty much, you know, we have a single value of estimating what the actual parameters will be, or we can use a range of values. So the range of values, we have more possibility of being wrong, because you have more different values, and then that now we associate that possibly being wrong with certain level of confidence. So formally, this is what being used more than just a single value estimate. So that's what the next video is going to talk about, is all this definition, all this example. So I'm going to go ahead and end this video here.